Good morning, students. Good morning. Okay, so we will discuss some more question on this topic. CT basic concepts of chemistry. Okay, so good morning to everyone. So, shall I start? Shall we start solving the questions? Okay, now we will move to the next one, and I think it's very simple. Next question is very simple. So that is 15th question. An organic compound contains an organic compound contains carbon 40%, then hydrogen 13.33%, then we have nitrogen 46.67%. So empirical formula is, that is the question. Empirical formula is, that is the question. Okay, so which are those options? Options are A, C2H2N. Option B is C3H7N. Option C is CH4N. And option D is CHN. So these are the options. Anyone? You can start solving. This is simple one. Even for board exam, you can expect this type of question. So an organic compound contains carbon 40%, hydrogen 13.33%, nitrogen 46.67%. So empirical formula they have asked. Okay, and the option is C2H2N, C3H7N, CH4N and CHN. Okay, so whether you people have started solving this? So you can see, you can read the question if possible once again. Then you can start solving the question. Okay, CH4N, option C, Chidwan. Okay, so even other student also I think they have written. Yeah, Suchita. Yes, even Chidwan had written option C. Okay, fine. Yes, I think you are right. So we will see. Now when it comes to answer, first what we have to do, whatever percentage is there, we will write that one in terms of grams, right? So hydrogen is 13.33 grams and nitrogen is 46.67 grams. So that's what the information is given to us. It was in percentage, now we have done it in terms of grams. Now we have to find out number of moles. Now we have to find out what is that number of moles. Say for example, with respect to carbon, molar atomic mass of carbon is 12 gram. So for 12 gram it will be 1 mole. How much for 40 grams. How much for 40 grams? Same way for hydrogen. So for 1 gram, atomic mass of hydrogen is 1. So for 1 gram it is 1 mole. How much for 13.33 grams? Same way when it comes to nitrogen. So we have nitrogen atomic mass as 14 grams. So for 14 grams we have 1 mole. How much for 46.67 grams? Right? That is nothing but given mass divided by atomic mass. It is same as that of mole is equal to given mass divided by atomic mass. So given mass is 40 gram. Atomic mass is 12 gram. Given mass is 13.33 gram. Atomic mass is 1 gram. Same logic is applicable for nitrogen also. Okay? So we are going to get the answer as 3.33. Okay, we are going to get the answer as 3.33. Here it will be same 13.33 only, and here it will become once again 3.33. Okay, so that's where we have the moles. 3.33 for carbon, 13.33 for hydrogen, and 3.33 for nitrogen. So naturally we can tell that molar ratio, if I want to find out, or straight away by seeing this value only we can tell, or if you want to find out the molar ratio, so what we have to do, we have to divide it by least number. So we have to divide all the three numbers by least number, that is 3.33. So 3.33 divided by 3.33, 13.33 divided by 3.33, right? Divided by 3.33. Then once again 3.33 divided by 3.33. So what is that you are going to get? Here it is naturally 1, here it will be 4, and here it will be 1. So therefore carbon is 1, hydrogen is 4, and nitrogen is once again 1. Naturally option C should be the answer. Option C should be the answer. Okay, so this is I think from CET. Now please remember, you can expect this type of question even for your board exam. So for board exam you have to write all these steps, but for competitive exams no need to waste in writing the steps and all. You can skip if you are thorough with the answer, but don't go with the wrong answer. Okay, so that's where we have the question. This is how we can find out the empirical formula. Okay, so that is just finding the molar ratio of the elements. Okay, so shall we move to the next one? Yes, yes, Dikshit, shall we move to the next one? We can write using table, sir. Yes, definitely you can write. That is for board exam, but for competitive exam, that's what I was telling. No need to waste your time. But for exam, board exam, yes, definitely you can use the table. So that's what even I have done. I have showed you in both the ways, in tabular form also or in other way also. Okay. So 16th question. I think this is from NEET. Okay. So in an experiment, it showed that it showed that 10 ml of 0.05 molar solution of 0.05 molar solution of chloride is requires okay, 10 ml of 0.05 chloride requires 10 ml of 10 ml of 0.1 molar solution of silver nitrate. Solution of silver nitrate. Okay. Which of the following will be the which of the following will be the formula of the given chloride. Formula of the given chloride. Okay, and they have given a condition, because in the options we have X2Cl2, option B we have XCl2, and option C we have XCl4, and option D we have X2Cl. So X2Cl2, XCl2, XCl4 and X2Cl. Okay, so therefore they have given one condition, that is X is any element other than chlorine. That is the condition they have given. That's what they have mentioned. Okay, so what is that question? In an experiment, it showed that 10 ml of 0.05 molar solution of chloride requires 10 ml of 0.1 molar solution of silver nitrate. So which of the following will be the formula of the given chloride? Where the condition here is X is any element, other than the chlorine. X is any element other than the chlorine. That's what the condition. Okay, option is X2Cl2, XCl2, XCl4, X2Cl. Okay, and some of you, I think you people have written option B. Okay, fine. So I think it's a correct answer only. People have written option B. Okay, so shall we solve it? So that's where we want to see the answer. Actually in question only we can tell, but anyway we will solve it off. Okay, now when it comes to XCl, we don't know which is that symbol. Just I have taken for given chloride. Okay, with X as the another element. For XCl, what is the amount of moles which are present in the 10 ml? That's what we are going to calculate. Okay, so for example, we have 0.05 molar, right? So that will be for 1000 ml. So for 1000 ml, it is 0.05 moles. How much will be there for 10 ml? So naturally ml will get cancelled. The given answer will be in terms of moles. So that will be 0.005 moles. 0.0005 moles. Or if you are getting confused, you can convert that one into millimoles, no problem. So which will be equals to millimoles means 0.5 millimoles. Anything is fine. You can keep in terms of moles or you can convert them into millimoles. Okay. Now, when it comes to silver nitrate is nothing but AgNO3. Silver nitrate is nothing but AgNO3, which you are going to use in your salt analysis once you start with your practicals. That's where we have the silver nitrate. Now silver nitrate, it is 0.1 molar. In the question itself we have one hint. Anyway, so for 1000 ml it is 0.1 molar. How much will be there for 10 ml? How much it will be there for 10 ml? So naturally it will be 0.001 moles, right? So 0.001 moles. If I want to next step, so then I can make it as 1 millimole. I can make it as 1 millimole. What my point? So that's what I can tell. Now if I observe here, straight away I can tell that 0.05, 0.1, it is double. Silver nitrate is double concentration. Same logic is applicable here also. So 0.51. So that means silver nitrate is double in the number of moles. Okay. So naturally, since the equation, since silver nitrate is double to that of the chloride solution with respect to the concentration, with respect to millimoles also. So therefore we can tell that the equation should be, see for example, I have XCl2. By considering XCl2 is the compound, silver nitrate, we have the silver nitrate as the another reactant. So they will get converted into silver chloride. They will get converted into silver chloride and X nitrate and X nitrate. So by assuming given compound is XCl2, you can try with H2Cl2, HCl4 or H2Cl. You cannot balance the equation. So one thing is compulsory, silver nitrate should be double to that of the chloride. That's what we have got the in terms of millimoles. Nitrate should be double. Okay. So it cannot be same. According to that one, it looks like it is same. So therefore we will make it as double. 2 molecules of silver nitrate. Right. So naturally here also I should make it as 2 AgCl. That's where I am going to get 2 AgCl. Now if I see this equation, 1 mole of given chloride, 1 mole of given chloride is reacting with 2 molecules of or 2 moles of silver nitrate. So 1 mole of given chloride is reacting with the 2 moles of silver nitrate. So that's what the given information also. So half it is, half of 0.1. So therefore, based on this we can go with B. All of you have given the answer, that is option B should be the answer. Option B should be the answer. The given chloride should be XCl2. All of you have understood? No need to even waste your time in converting millimoles also. Directly you can see the information in question itself. Okay? So therefore, option B should be the answer. Very good. All of you have understood? Any doubts with regard to this? It's actually very simple question. Only thing is you can read it properly, because they have given in question itself that silver nitrate will be double the concentration of given chloride. Okay? So naturally when you convert that one into moles or millimoles, it has to become double. Since concentration itself it is double. Okay. Shall we move to the next one? Okay. So if you don't have any doubt, shall we move to the next one? Okay. So 17th one. We will move to 17th one. 6.02 into 10 to the power of 20 molecules of urea are present in 100 ml of its solution. Okay, so the concentration of solution is, see, this is also from NEET. So concentration of solution is, okay, so option A 0.001 molar, option B 0.1 molar, option C 0.02 molar, and option D 0.01 molar. So that's where we have the question. 6.02 into 10 to the power of 20 molecules of urea are present in 100 ml of its solution. The concentration of solution is, so which are those options? Option A 0.001 molar, option B 0.1 molar, and then 0.02 molar, and option D is 0.01 molar. Okay, so any one of you? Okay, Stephen has given the answer as option D. Stephen has given the answer as option D. Okay, so fast people are solving, very good. So answer, so you people have given it as option D. We will see whether option D will be the answer. First we have to find out what is the moles of solution, because molarity is equal to number of moles of solute, so that is in this case urea, divided by volume of solution. Okay, so in this case they have given it as 100 ml. In this case they have given it as 100 ml, right? So which is that solute? Urea will be the solute. So therefore they have given molecules, so we have to say this many number of molecules corresponds to how many number of moles. Okay, so in that case we can use the Avogadro's number information. So 6.02 into 10 to the power of 20 molecules corresponds to the number of moles equal to, so which information we should use? Avogadro's number, right? So that's where we have 6.02, I will take it as 6.022 into 10 to the power of 23, that is Avogadro's number. So that corresponds to 1 mole. So in that case, how much for 6.02 into 10 to the power of 20? Into 10 to the power of 20. So what is 6.022 into 10 to the power of 23? That is Avogadro's number. So always we know Avogadro's number corresponds to 1 mole of that particular substance. So therefore Avogadro's number of the molecule, that is urea, corresponds to 1 mole of urea. So these many number of urea corresponds to how many moles? Okay, so that's where we have got the answer as 0.001 moles. So we have got the answer as 0.001 moles. But okay, it's moles, it's not molarity. So all of you, whatever I have written, it is correct only. Okay, it's not molarity. So this is molarity, that is moles. So some student they will go with option A. Okay, but you people are written properly. So therefore, molarity is equal to number of moles of solute. How much we have got? 0.001 moles. Volume of solution in liter it should be. So they have given 100 ml. So it should be 0.1 liter because 1000 ml corresponds to 1 liter. So naturally 100 ml corresponds to 0.1 liter. Okay. So divided by 0.1 liter. Got my point? Directly you can do like this, 0.1 liter directly. Okay. So that's where we are going to get the answer as 0.01 molar. Or you can make it as for 100 ml, it is 0.001 moles. How much for will be 1000 ml. That is also fine. Okay, what I will do is, instead of writing like this, another way is, for 100 ml, this will be 0.001 moles because they have asked concentration. How much for 1000 ml? How much for 1000? I think this is the better way. So for 100 ml it is 0.001 moles according to their information. How much will be there in 1000 ml? Because volume of solution in liter it will be. Okay na? So therefore this is where we are going to get the answer as 0.01 molar. 0.01 molar. Option D should be the answer. All of you have got? So earlier I wrote it as 0.1 liter. So straight away we cannot do. That is because for 100 ml they have given this one. Whatever moles we have got, that is for 100 ml. Okay. So therefore better to go for 1000 ml. How much it will be? Then you are going to get the answer. Okay. So in that case we will move to the next one. Option D is the answer. See, that's what we can see, whether it is JEE or whether it is NEET or whether it is CET. If you are thorough with your NCERT textbook, if you are 100% thorough with your NCERT textbook, all these exams you can face easily. Okay? All of you have understood. So therefore my suggestion here is, first practice the NCERT book. Make thorough with your NCERT textbook. Then you can go for competitive exam books. Okay? So next one. Question number 18. Next one is question number 18. The mass of the mass of 112 centimeter cube of ammonia gas at STPEs. So option A. So 0.085 grams. Option B. 0.850 grams. Option C. 8.500 grams. And option D. 80.500 grams. Okay. So I think this is from NEET if I am remembering, but I don't know properly. I think from NEET only. The mass of 112 centimeter cube of ammonia gas at STP is option A 0.085 grams, option B 0.850 grams, option C 8.500 grams, and option D 80.500 grams. Okay. So can any one of you try it out? Anyone? All of people have started solving this? They have given the volume of ammonia. Okay, they have given the volume of ammonia at STP. Okay, na? At STP. Okay, you people are writing as option A. Okay, fine. Option A. We will see. All of you have written as option A, which is correct. Okay. So, what is STP? Standard temperature and pressure. What is that? Temperature, which is very important. Standard temperature and pressure. That is 0 degrees Celsius. Okay. So, room temperature, it will be 25 degrees Celsius. But STP, that means we are talking about 0 degrees Celsius. So, naturally, we should consider the molar volume. We should consider the molar volume as 22.4 liters. Please remember, molar volume can be expressed in two numbers. One is 24.7. One is 24.7 and another one is 22.4. So we have two values, 24.7 liters and 22.4 liters. So this molar volume is meant for the room temperature, and this is molar volume at STP, where it will be 0 degrees Celsius. Okay, so therefore we have to apply the suitable molar volume value. Since they have talked about STP, we have to consider the second one, not the first one. We will consider the second one, that is 22.4 liters. So according to that, liter can be converted into ml, right? Since they have given in centimeter cube, I can convert this one into ml, because 1000 ml is equal to 1 liter. That is the information what we know. So 1000 ml is equal to 1 liter. So in that case, 22.4 liter will become 22,400 ml. So 22,400 ml. All of you will agree? Now, ml can be written in centimeter cube. ml can be written in centimeter cube. So therefore, I can write that for 22,400 centimeter cube, for 22,400 centimeter cube of ammonia corresponds to how much mass? How much mass? What is the molar mass of ammonia? So molar mass of ammonia should be NH3, right? So nitrogen is 14 into 1, only one nitrogen is there, and 1 into 3, since we have the 3 hydrogen. So altogether it will become 17 gram. So 17 gram is the molar mass of ammonia. So therefore it is 17 gram. Why? Because 1 mole of ammonia corresponds to 17 gram. 1 mole of ammonia corresponds to 17 gram. And this is the volume of 1 mole of any gas. This is the volume of 1 mole of any gas. Therefore, when I am talking about molar volume, so it corresponds to 1 mole of that particular gas. Therefore, it should be molar mass, 17 gram. Right? So that will weigh approximately 17 grams. So in that case, mass of therefore mass of 112 centimeter cube of ammonia is, okay, now we can easily find it out. So for 22,400 centimeter cube, it corresponds to 17 gram. How much will be for 112 centimeter cube corresponds to? Centimeter cube will get cancelled. So the answer will be in terms of grams. So if I am right, it will be 1904 divided by 22,400, which is nothing but 0.085 grams. 0.085 grams. As people have told, option A should be the answer. Option A should be the answer. All of you have understood? Any doubt? So whether it's clear? So that's where we have the option A as the answer. It's very simple. Only thing is, this question is based on molar volume concept. You should know about the molar volume, and you should know which molar volume value we should add, because it can be 24.7 or it can be 22.4. So depending on the condition they provided, you should apply that particular value. Okay? So whether I am clear? Shall we move to the next one? Or fine, what I will do is, I will move to totally next chapter itself. Otherwise, this chapter only I will be solving. So what you can do is, you can solve some more problems related to this particular chapter. Okay, you can solve some more problems. Don't see whether it is NEET, CET or whatever it is. You just solve the problems. Okay, so it can be a variety of problem which you have to solve, not same type of problems. So don't see with respect to CET, JEE or NEET. It can be any of that. Okay, so yes, Rohan, we are going to start with the next chapter, that is structure of atom. Oh, next chapter means not periodic classification. I have to finish the competitive exam, this one related to this particular chapter also. Then only we will go to the next chapter. Okay, so we will start with the structure of atom. Okay, so hagadre, when I am talking about structure of atom, which is that first concept? Sir, for day after tomorrow, test for how many marks? Will you give this sum? Okay, Stephen. So that I don't have much idea. Anyway, I will discuss with the teachers, or they will only tell you. I will ask them to inform you people. Okay? So don't worry. So I will discuss with them. Okay, already I think they have announced. Stephen. Okay? Nirupit has given the answer, 25 marks. Okay. Okay now? So in that case, shall we move to the next one? Structure of atom. Okay, fine. Hagadre, when I am talking about structure of atom, which is that first concept you people have discussed, that is related to atomic models. Now when I am talking about atomic models, so before that, discovery of electrons was there. Cathode rays, canal rays. So on that you can expect question in a statement form, which is true and which is false. Like that statement you can expect from cathode rays or canal rays. Problems will not come from that particular portion. It can be a statement type of questions. Okay. So after that we have come with the atomic models. Even in atomic models, with respect to Rutherford's atomic model and all, you cannot expect much questions. Once again it will be like true or false. Now comes the hydrogen spectra, or we will go with Bohr's atomic model. Bohr's atomic model. So that's where from this particular part you can expect the questions. Not only for board, even for the competitive exams. You can expect some of the problems also from this regard, from this particular part. Even isoelectronic species we have discussed when we were talking about Bohr's atomic model only. So isoelectronic species. If you recollect, we have discussed about hydrogen and hydrogen-like species, and that's where I told hydrogen-like species and hydrogens are examples for isoelectronic species because they have same number of electrons, right? So isoelectronic species can be a combination of atom and ions, or it can be a mixture of ions. Anything is fine. Okay, but it cannot be atoms only. No, all the atoms cannot have the same number of electrons. It should be one atom and others will be the ions, or it can be all of them can be the ions. Only then they can become isoelectronic species. Okay, so then you can expect question from hydrogen spectra. Once again, problems can be asked. Once again, problems can be asked based on hydrogen spectra, which we have solved with respect to board exam point of view. Okay, so that is with respect to hydrogen spectra. So once it is done, then we have discussed about quantum mechanic model. Then we have discussed about the quantum mechanic model, right? With related to structure of atom. Quantum mechanic model related to structure of atom. So that's where we have the quantum numbers. And as I told, not only for board exams, these are very important even for the competitive exams. You can expect problems related to this quantum numbers. Okay, fine. Here I have to include even de Broglie's equation. Okay, small d should be. So de Broglie's equation and Heisenberg's uncertainty principle. So de Broglie's equation. Okay, so then Heisenberg's principle. On this you can expect the problems. Heisenberg's principle. Okay, so that's what another important one related to your examination point of view. Okay, so what is that? Vishwas, for how many marks, sir? Okay, you are talking about this topic, right? So structure of atom, you can expect around 2 questions for NEET and all, maximum 2 questions, because you will be having both first PU and second PU. So 2 to 3 questions will be indicating that it's a pretty good important chapter, because some of the chapter it cannot be having any question at all, depends. Okay, so from this chapter you can expect for 2 questions and all. Okay, and that is pretty good amount of question only. So de Broglie's equation, Heisenberg's principle. So even from that point of view you can expect the questions, and from here also you can expect the questions. And finally, electronic configuration. Please remember, related to electronic configuration you can expect the question, even for the board also, even for the competitive exam also. They can ask any of the atomic number and they will give the options also. Then you should be able to find out which is the appropriate answer for that. And once again, as usual, always I will be telling, try to practice minimum 35 to 40 elements of your periodic table. Okay, so minimum that many number of elements you should be practicing with respect to that atomic number. Okay, fine. So this is related to introduction for this particular chapter. So we will solve first question. Which one of the following which one of the following following sets of ions, following sets of ions represents the collection of represents the collection of isoelectronic species. Isoelectronic species. This is from CET. So K plus, first combination Cl minus, magnesium plus 2, scandium plus 3. Okay. So option B, sodium, calcium plus 2, scandium plus 3, then fluoride F minus. Option B, option C, it should be option C. It should be option C. K plus, potassium plus, calcium plus 2, scandium plus 3 and chloride. And option D will be Na plus, magnesium plus 2, then aluminium plus 3, then chloride. So these are the options. Given. All of you can see the board. So that's where option A is K plus, Cl minus, magnesium plus 2, scandium plus 3. Option B is Na plus, calcium plus 2, scandium plus 3, F minus, fluoride. Option C, K plus, calcium plus 2, scandium plus 3, Cl minus. And option D is Na plus, magnesium plus 2, aluminium plus 3 and Cl minus. So first and very important thing here is, to answer this particular question, you should know what is the atomic number of these elements. That's why I told up to 40 elements at least you should practice with respect to atomic number. Got my point? Then only you can answer this particular question. Say for example, if I take potassium. So potassium is having atomic number of Okay, fine. What is the option C? Yes, option C is correct. But can you tell me what is the atomic number of potassium? Yes, it should be atomic number of potassium is 90. If that is the case, when I am telling K plus, okay, we will go with answer now. Okay, so since the people have written as option C, we will try to find it out. Atomic number of potassium is 90. So since I have written K plus, how many electrons are there? 18 electrons are there. Okay. So what about calcium? What is the atomic number of calcium? Any one of you? Atomic number of calcium? What is the atomic number of calcium? Yes, very good. They are the neighbors. They are the neighbors. Group 1 element, group 2 element. So that's where we have the potassium. 2 plus, that means 20. So 2 plus means 2 electrons are absent. So we have got 18 electrons. What about scandium? What is the atomic number of scandium? What is the atomic number of scandium? Yes, very good. Once again, they are the neighbors. Scandium plus 3, 21. So plus 3 means 3 electrons are lost. So from 21 minus 3, that is once again 18 electrons. So what about chloride? What about chloride? What is the atomic number of chlorine? What is the atomic number of chlorine? It should be 17, because this is the answer we know, right? It should be 17. So naturally 17 plus extra electron. So therefore 18 electrons. So that's where we can see all of them, they are having same number of electrons. All of them, they are having same number of electrons. So here we can easily reject because magnesium is present. Magnesium belongs to totally different period. So potassium, calcium, they are neighbors. But magnesium, which belongs to same family, that is calcium group only, but it is in different period. So atomic number will be totally changed. So option A is gone. So here sodium and calcium, they are giving together. No, it cannot be possible. Even fluoride is there, that is fine. But here only we can reject straight away. Right? So when it comes to here, so Na plus chloride, they have given the combination. No, we can straight away reject. So therefore option C should be the answer. Okay? So for competitive exams, you should logically think as soon as possible, you should go for proper answer. No need to waste in calculating. This is to show you how much atomic number will play important role in solving this type of question. That's why I have written like this. But if it is asked for board exam, then yes, you have to show like this only. Okay? So any doubts? So option C should be the answer for this particular question. Option C. Okay? So we will move to the next. Yes. So we will move to the next. Once again, I have taken the same type of question, which is not isoelectronic with, which is not isoelectronic with other three. Okay, so that is option A, carbon monoxide, option B, NO plus, option C, Cn minus, and option D, oxygen. So among these options, you should select which is not isoelectronic. Okay? Any one of you? Only thing is, once again you should know atomic number. Once again you should be knowing atomic number of each elements present here. Then only you can talk about isoelectronic species. Anyone? So what I mean to tell you is, what is the total number of electron in carbon monoxide? That one you should know. What is the total number of electrons present in carbon monoxide? Stephen has written oxygen. Stephen has written as oxygen. All of you will agree with that? We will see. I think it's a correct answer. So now when I am talking about carbon monoxide, carbon is having 12 electron. Oxygen is having how many electron? 16. So total electrons it will be 28. Right? Now same way, when I am talking about Na plus, so nitrogen is having how many electron? 40. So nitrogen 40, oh sorry. So I'm making it as atomic weight. I'm taking it atomic weight. No. So carbon is 6 and oxygen is 8. Na? So that's where we have 14 electrons. That time I took atomic weight. So here it is 7 plus 7. Okay, 14 electrons. So when it comes, okay, 7 plus 7, no, it should be O plus, right? Okay, fine, correct only. So why I have taken 7 here? Because O positive is there, 1 electron less. So carbon and nitrogen minus, that means 6, nitrogen is 7 plus another 1 extra electron, so 8. 6 plus 8, once again 14. Oh, naturally it should be oxygen only. Naturally option D should be the answer, because when it comes to oxygen, it will be 8 plus 8, that is 16 electrons. 8 plus 8, that is 16 electrons. So naturally oxygen is the one which is having different set of electrons. All the others, they have 14 electrons. Fine? All of you have understood? Anyway, I will stop here. So on Saturday we are going to continue with the same topic, structure of atom. We will solve some more questions related to this particular chapter. So what you can do is you can solve some more questions related to first chapter also, so that you can have a practice. So I will stop here. Oh, sorry. Okay, thank you everyone.